Okay, see here now. First, we are taking the questions from your textbook. What is the number of reactants in each of the above reactions? Okay. So now in each of the above reactions, what is the number of reactants? I'll just take up all these reactions starting from here. Okay. You can see here there is only one plus sign over here. So 1 and 2. There are two reactants. Same way I'll take the other reaction. This magnesium and oxygen. Here also there are two reactants. Here calcium oxide and water. Here also there are two reactants. Then the next question that is asked is what is the number of molecules of reactants taking part in the above reactions? Now, number of molecules. How do we get the number of molecules? Whatever the number is written here in front, this is going to be the number of molecules. Here there is no number, it means here it is 1. So here in this reaction, two molecules are taking part in the reaction. Then here 2 is there. Here there is no number, it means here this will be 1. So the total number of molecules in the reactant side is going to be 2 plus 1, that is 3. Okay, we'll take one more reaction that is in the above part. Here also you can see there is no number, it means this is 1. Here also no number, it means it is 1. So total number of reactant molecules is 1 plus 1, that is 2. Okay. The next question that we are taking, the third question that we are taking over here is how many products are formed in each of the above reactions? They have not asked product molecules. They have asked how many products. Okay, I'm also going to ask you how many product molecules are there. Okay, on the right hand side, you can see there is NH4Cl. Okay, so only one substance is formed. Here also only one substance is formed. Here in this reaction also there is only one substance formed. Only, no, heat will not be considered as a chemical product. It will be in the form of energy. So heat is not taken as a product. Only one is going to be the product. Now, if I'm going to ask you how many product molecules are there, that question is not given, but still I will discuss that part. How many product molecules are there? There is no number over here. It means this is going to be one product molecule is there. Here there the number is 2. It means the number of product molecule is 2. Two molecules are formed, but only one product is formed, that is MgO. Okay. Here also there is no number. So the number of product molecule that is formed is only 1. If you have this reaction, yes, heat is given out. This reaction is an exothermic reaction. We'll move on to the next part. Okay, now in our last class, we had done on the basis of the arrangement of atoms. There are 4 types of reactions. The first reaction definition we have already done, that is combination reaction. Here we had seen that 2 or more substances combined together to give only one product. So on the right hand side, you are going to have only one product. There may be 2, there may be 3, there may be 4 reactants. How many ever reactants are there, that doesn't matter. But on the right hand side, there is only going to be one product. Now the second type of reaction that we are taking is opposite of the first type. Here we are going to have only one reactant. There may be 2 products, there may be 3 products, there may be 4 products. How many ever products, number of products are there? But the reactant is going to be only one. Yes, what is your question? Here it is going to be, the name of the reaction is decomposition. Some form of energy will have to be supplied. If you are going to supply heat energy, then it is going to be endothermic reaction. But decomposition we have to write, but depends on what type of energy we are supplying over here. If we are supplying heat energy, then obviously we had seen yesterday, we have to put a triangle over here. It means heat energy is supplied and the reaction is going to be endothermic. But we can also supply some other form of energy. For example, some reactions are there which take place because of sunlight. So here we are going to write light over here. So that reaction we will not call it endothermic because we are supplying light energy. Of course, it is going to be decomposition only. Okay. Then if you are putting a triangle over here for this, then it is going to be endothermic reaction. You can supply electrical energy also. For example, electrolysis of water. Okay, when you pass electric current through water, it will split up into hydrogen and oxygen. We are going to write down this reaction. What is present? Not sodium chloride will not. So it will. It will. We will see those when we do the chapter of electrolysis. Okay. So right now we are doing definition of decomposition reaction. Okay, it means you are breaking up a substance by supply of some form of energy. So here there is only going to be one single reactant, or it may be going to give you two or more products. So the main important part over here is there is only one reactant. We'll just have a look at the definition of decomposition reaction, and you are going to take down the examples also. Okay, so this is decomposition reaction. Okay, the chemical reaction in which two or more products are formed from a single reactant. This single reactant word is very important. This is known as decomposition reaction. The first example of this is the formula of sugar is given C22 C12H22O11. By supplying heat energy, it decomposes into carbon and water. Okay. It will be endothermic because there is supply of heat energy. You can write heat also over here. Uh, Both you will have to write. Okay, you will have to write. If they say only identify, then you have to write both of this. It is decomposition reaction. It is endothermic reaction. If they ask you state whether the reaction is endothermic or exothermic, then it is going to be endothermic. You can also put a triangle over here instead of writing heat. The second example is calcium carbonate, CaCO3. This, when it is heated, you can see there is a triangle over here. It gives you calcium oxide and carbon dioxide. You can see also over here, the physical states are also mentioned. This is solid. Calcium oxide is also solid. And here an arrow is upwards. It means it is a gas. Okay. H2O2. This is hydrogen peroxide. It gives you water and oxygen. This reaction takes place in presence of light. What is H2O2 hydrogen peroxide? Okay, this is hydrogen peroxide when it basically it is a cleansing liquid, phase cleansing liquid which is there. It contains hydrogen peroxide. It has to be stored in the dark bottle. Why? Because if light falls, then this oxygen will escape out in the atmosphere and only water will remain in the bottle. Okay. So here light is going to be the factor that is going to cause this reaction. I'll give you some time. You can note down all of the things that are there in the screen. Decomposition because there is only one reactant. Huh, this is also because there is only one reactant is there. You can see on the left hand side, there is only one substance. Therefore, it is decomposition reaction. These both are caused because of heat. The last reaction, this 17 number which is there, it is caused because of light. Okay. No, you will just write above this, you are going to write light over here. As heat is written over here, here above this, you just write light. Okay, you will just take down all of this. If you have more questions, you can ask me. Okay, for this sugar C12H22O11, the physical state is not mentioned. You can write because this is a solid. You can, in the bracket, you can write S. Even carbon also is a solid. So for this also you can write S. This water which is there, because of heat, it should be considered into a liquid state. Because of heat supplied, okay, it escapes out as steam. So for this we are going to write it is going to be in the gaseous state. Okay, just look at screen over here. The experiment is same only. Okay, the reaction which we have written right now, CaCO3, calcium carbonate. This is when it is heated. It is going to produce calcium oxide and carbon dioxide. Now the apparatus that we are looking over here, okay, here a test tube is there in which calcium carbonate is present and heating is carried out. Obviously, the calcium oxide solid which is there, it is going to remain here in this test tube only. But the carbon dioxide gas which is there, with the help of delivery tube, this part, this U tube inverted which you are seeing is called delivery tube. We are going to pass it through lime water. Lime water is basically again calcium hydroxide only, CaOH twice, CaOH bracket twice. When carbon dioxide is passed through lime water, it turns cloudy or it becomes milky. Okay, I'm going to show you this experiment. I'll also send you the link in the group, and I'll make you write that reaction. Okay, I don't think so that reaction is given over here, but still I'll make you write that reaction. The next part that which is there, again, this is the example of decomposition reaction. Water when it is electrolyzed. I'll show you that reaction also. I'll send you the link also. Hydrogen and oxygen is produced. Here, hydrogen will be produced at cathode, oxygen will be produced at anode, but this we will see that in the chapter of electrolysis. We will see both of those reactions, and I will send you the link for both of this. That is, this lime water is turning milky, as well as electrolysis of water producing hydrogen and oxygen. We'll see both of these experiments, and I'm going to send you the link, which also you can see it again. You can take down the reaction. Electrical energy is supplied. This is electrolysis of water producing hydrogen and oxygen. Hydrogen will be produced at cathode. And oxygen is produced at anode. Now see, this is how we are going to carry out electrolysis of water. I have already sent you the link in the group.
If we connect an electrolyzer filled with distilled water to a source of direct current, we can observe a slow evolution of gases. After some time, we notice that the volume of the gas released at the cathode is double that of the gas formed at the anode. To identify the gaseous products of the reaction, we collect each gas in a test tube and check its behavior in the presence of a glowing splint. The characteristic cracking sound proves that the gas released at the cathode is hydrogen. The ignition of the glowing splint is evidence that the gas collected from the anode is oxygen, which supports combustion.
This is lime water test. Calcium hydroxide is taken. It is passed through lime water. You see the appearance on the in the test tube. Is going to become cloudy or it is going to become
hopefully
milky.
you can see that the lime water is.
I'll also give you the reaction for that. You can write that reaction down. Calcium hydroxide CaOH twice. This is lime water plus carbon dioxide. This will give me CaCO3 plus H2O. Because of this calcium carbonate, this appearance becomes milky or cloudy. This is calcium hydroxide. No, it is in the form of solution, so it is aqueous. It is very slightly soluble in water, but because it is aqueous, it is water soluble. Therefore, here we are writing AQ. And of course, this is a gas. Calcium carbonate is a solid and water is a liquid. You can copy down that reaction. See the third type of reaction that we are taking, as we had seen in our last class. Displacement reaction is replacement of atoms. So the general equation for this will be A plus BC. A will go with C and B is out. So this is replacement of atom. This kind of reaction is called displacement reaction. So we have the definition of displacement reaction as well as these examples which we are going to complete it. The reaction in which the place of an ion of less reactive element in the compound is taken by another more reactive element by formation of its own ions is called displacement reaction. See the first example over here, copper sulfate plus Fe. Copper sulfate is CuSO4. Fe is iron. Iron is more reactive than copper. So what happens over here? Copper will be out because it is less reactive. So this is going to be giving us Cu and Fe will go with SO4. It is going to become FeSO4. So here the displacement of iron Fe is taking place instead of copper. This kind of reaction is displacement reaction. Copper is less reactive, which is as given in the definition. The physical states over here, copper, obviously here copper metal is formed solid. And FeSO4 again here this is aqueous. Okay, copper sulfate is a blue solution while FeSO4 is a green solution. So if you put iron nails in the solution of copper sulfate, after some time you will be able to see the solution has become green and the iron nails have coated with reddish brown copper metal. The second reaction, obviously here lead is more reactive than copper. So Pb will go with SO4. It is going to become PbSO4. And this is going to give us again copper metal. Just take down all of this. If you have any questions, you can ask me. See the last type of reaction depending upon arrangement of atoms. Okay. This is double displacement or double decomposition reaction. In this reaction, both of them are ionic compounds, both of them are water soluble. They will mutually exchange their ions, mutually exchange their positions. Over here, A goes with D, C goes with B. Always the positive part of it will be written first. So AD plus CB. This is mutual exchange of ions. Last time, previous classes, I have given you example of potassium iodide with lead nitrate. So that reaction also we are going to write down. We will write down the definition of double displacement or double decomposition reaction. It's also a precipitation reaction because an insoluble substance is produced in it. So the definition over here, the reaction in which the ions in the reactants are exchanged to form a precipitate is a double decomposition reaction. Okay, just pay attention here. Potassium iodide, the formula is Ki plus lead nitrate is Pb bracket NO3 twice. This gives us K will go with NO3. The formula is KNO3. No, both the valencies are 1, 1. Pb will go with I. The formula is PbI2. This is the precipitate, so it will be solid. It's a yellow precipitate. I'm also going to show you this reaction. Okay. This is aqueous. Yes, lead iodide is not water soluble. I'll show you the reaction. And of course, both of these are also aqueous solutions. Yes, one of the products is going to be insoluble in water. This equation is not balanced. Over here, you can see I is 2, PbI2. To make this balance, I'm going to multiply this by 2. This makes 2K also. Potassium is also 2. So this also makes 2. And the NO3 part also is already double. This is the balanced equation. You can take down this reaction. Just wait, I'll show you that experiment also. You can see this experiment, how the addition is taking place. This is lead nitrate. You can see the yellow precipitate. PbI2, lead iodide. You'll take down these, whatever is there on the screen. If you have any questions, you can ask me.